Now let's take a look on this problem. The problem over here asks us to design for the wood beam below. So similar to the steel design problem, over here we have the fixed support here. We have a person with around 180 pounds, so which means that one is a concentrated load. The length of the beam is 15 feet. We have the type of the wood over here, that is ball cypress, select structural. So you can draw that one in a simple load diagram like this. We have every information except the size of the wood over here. So what is the appropriate size for this wood? We're going to design for that. So first of all, you need to go to the formula sheet over here. And because we need to design for the wood beam, so we're gonna use all of these formula. Step 1, similar to the check for the wood beam. For the design one, step 1 and step 2 is to calculate the design bending stress, the design shear stress over here. The problem is that I don't know if the wood beam we select is a lumber or timber. So the rule of thumb is that you pick the larger number, or sorry, the rule of thumb is that if you have both lumber and timber in the table over here, then you just pick the smaller value for safety for the design. If you have only you see only one table have that type of wood, then you just pick that value. Okay, so we have here is the ball cypress. So let's go here. If you check on the bottom over here, you see ball cypress appear on the table 4A. And let's see, we don't have ball cypress on table 40. So it's very easy now. We just have only one option. Therefore, we just pick the pack over here. The one we need to check for is select structural. Select structural, so which mean let me highlight here this pack over here. Let me delete all of this. Okay, select structural. And we need to check for FB and FV. So the FB we have is 1200 and FV we have is 160. So we have FB is 1200 psi. Step 2, you have the FV will equal to 160 psi. Now step 3. Step 3 is to find the M max, and step 4 is to find the V max over here. Over here, M max equal to step 4, V max equal to previously I used the software, so now maybe let's try the reference, the formula reference. So let's open, go to canvas here, open the shear moment deflection diagram, and then I need to check for the fixed support with concentrated load. Fixed support with concentrated load. Oh, I don't have that, the reference for that. So that means I need to use either software or manual method. So let's try software. So we have 15 feet. And then we have only one fixed support at 0. And then we have 180 pound at the free end over here on the right hand side. So 180 at 15 feet. So like that. All right, so the air max we have is 2700 and the V max is 180. 2700 pound foot and the V max is 180 pound. This one, let's convert that to pound inch. It will equal to 32,400 pound inch. Next step is to wood beam. All right. Next step is to calculate the S mean or the minimum required S. S mean will equal to M max divided by the large FB multiplied by the FOS. So you're gonna have step 5. We have M max divided by FB S mean will equal to M max divided by large FB multiplied by FOS. So we're gonna have M max will equal to 32,400 divided by the large FB is 1200 and the FOS we know in the problem is 2. So just multiply by 2. And then we're gonna have 54 inch to the power of 3. Let's put the unit over here. And right here we have is PSI. Okay. All right. Now let's go to step 6. Step 6 is to calculate the A mean. A mean will equal to 3V max divided by 2F V multiplied by FOS. So we have V A mean will equal to 3V max divided by 3V max divided by 2 FV multiplied by FOS. Alright, so we have here V max is 180 and FV is 160. FOS is 2.0. So we're gonna have the A mean will equal to 3.38 inch to the power of 2. Alright, then step 7 over here is to look for the wood size table and then select the one that have the S larger than S mean and A larger than A mean. So for step 7, then I can look for the table here, table over here, and the S mean to maximize the use of the material similar to the previous problem. I will use the strong direction, so which means I will pick SX or the larger S. I need the SX larger than 54 and A need to larger than 3.38. So let's take a look here. Let me clean this one a little bit. So SX is over here, and we need to find SX larger than 54. So right here we have this one is 3 by 14. We have SX is 73. That one is way larger than 54 54. This one is will larger than 3.38. So this one will work. However, let's find the other option that may be more economical. So in the exam, if you select 3 by 14, that is still correct. However, in the real life, this one, even though it's correct, but maybe not a good option because it you can still save money for this one. So let's pick another option. Let's try. Oh, maybe that is probably the best option. We have another one over here is A by A. That is 70.3. However, that is not much different with the 73 over here. So either of the two options over here can be a good one, because this one have the cross-section area is smaller than this. So that means this one we have we use less material. This one we use less material, and this one will be cheaper. So let's pick 3 by 14. This one is not a typical size. This one is not a typical size in the industry. Let's pick this one. So 3. We can use 3 by 14 with the S of X equal to 73.15 inch to the power of 3, and A equal to 33.13 inch square. Or we can also use A by A as well with S of X equal to 56.25. 70.31. 70.31 inch to the power of 3, and A equal to 56.25 inch square. So either of the two options will work.